Very good morning to everyone. And today we are going to discuss the lecture number one of electricity. Okay. Lecture number one. So in this electricity chapter, we will study about what is in the first lesson. First session, we will discuss about what is meant by current and what are the types of currents we are having. Okay. And then how the electric current it gets appear here. You can see that. So current means that is nothing but a flow. So here we are having the electric current means flow of electricity is nothing but electric current. So for example, if you see that flow means look at the example here water flow is there. So we call it as water current. Okay. When water flows from one place to another place is called water current. And at the same time, if the wind flows from one place to another place, we call it as wind current. Is that right? Like that, if the current electricity flows from one place to another place is known as electric current. So the flow of charge from one place to another place. Is it right? The flow of electrons in a conductor is known as electric current. Or the electric current is the amount of charge flowing through the a particular cross section area in a unit time. So in another word, what we can say is that the rate of flow of charge, the rate of the rate of flow of charge through a conductor, through a conductor is known as electric current. Okay. So here the rate means per second. Rate means per second. So in 1 second, the flow of charge through a conductor is known as electric current. So the electric current is the amount of charge flowing through a particular cross section in a cross section in a unit time. Okay. Same definition for the electric current. So this is the cross section area of the conductor. Okay. And to this cross section area, the amount of charge which is flowing per second is known as the rate of flow of current. Okay. So electric current is equal to amount of charge, that is number of coulombs per unit time. Okay. So I, electric current is denoted by I. Okay. So here electric current is equal to I is equal to the amount of charge is nothing but in terms of coulomb denoted by Q. Okay. And per unit time is T. So I is equal to Q upon T is the formula. Okay. What makes the charge flow? Basically, we know that here if you take tank A and tank B, two different tanks, for example, and tank A is little bit at a more height and tank B is at bottom compared to tank A, and then connect a pipe between tank A and tank B, and there are walls. So if the water is in the tank A is connected to tank B, slowly what happens after sometimes you can see that the water automatically flows from tank A to tank B without any external source. Is it right? It means if the availability of the energy is there, which is from a higher state to lower state, it can flow easily. Is it right? So, if the temperature of tank A is 60 degrees and the temperature of tank B is around 20 degrees, when the wall is open, if you imagine that a hot water is in tank A and the cool water in tank B, automatically they will combine with each other. Is it right? So after sometimes, what happens? This 40 degrees, this 60 degrees temperature water, okay, is in contact with 20 degrees temperature water, okay. So after sometimes, the whole water will comes to an equilibrium state by increasing its temperature and by decreasing its temperature automatically without any external source. because they are in contact with each other. So the average temperature of the whole water is equal to 60 degrees plus 20 degrees by the total quantity is in two terms, that equal to 80 degrees by 2, that equal to 40 degrees. So what is the 40 degrees Celsius? What is the average temperature of the complete water? So the average temperature is equal to 40 degrees Celsius, that is equilibrium temperature. Equilibrium temperature. Okay. Like that, we can see that the cell or a battery. The battery is nothing but the combination of two or more cells together. Okay. Now look at a cell which is having two terminals. One is positive terminal, another is negative terminal. Okay. Now we can see that this is how looks like the cell exactly. Okay. In this we can see the charged particles. Here positive charge terminal and negative terminal. Okay. So this is a positive terminal which is at a higher electric potential. Higher electric potential. Here we are having more energy level. Okay. And here we are having less energy level. So this is what we call lower electric potential. When these two are connected, when these two are connected to any device, so the flow of potential, electric potential will takes place from higher potential to lower potential like this here, higher potential to lower potential automatically. The difference between the higher potential electric potential and the lower electric potential is nothing but what we call potential difference. Potential difference. Potential difference. Is it clear? So here you can see that the flow of charge from positive terminal to negative terminal. Okay. So that is nothing but what we can say potential difference, higher electric potential. Okay. So the difference between higher potential and lower potential is known as potential difference. In other words, what we can call it as the potential difference is also known as voltage. So the function of the cell is to create potential difference only. What is the function of the cell? The function of the cell is to create potential difference between the positive terminal and negative terminal. Is it clear? Now, what is a free electron? Basically, we know that this is a nucleus. Around the nucleus, we are having some orbits, and at the nucleus, we will have protons and neutrons. Okay, in a fixed orbit which are around the nucleus, we can see that these are the fixed orbits, also known as main shells. Okay, so these on these main shells, we can see that the free electrons can revolve. Okay, these are the free electrons. They revolve in a particular orbit. So we know that in any orbit, maximum 8 electrons we can fill here, except the first orbit, because in the first orbit the capacity is only 2 electrons. Okay, you can see this. The distance between the nucleus and the orbit you can measure in terms of the strength here. So between the nucleus and the electron there is a force of attraction called electrostatic force. What we call that is known as the attraction of force between the electrons and the nucleus is known as electrostatic force of attraction. Okay, so this force is nothing but electrostatic force of attraction. In nonmetals, the number of electrons in outermost orbit is more. Okay, in nonmetals, the number of electrons in an outermost orbit is mode. Outermost orbit in the sense this is the outermost and this is the innermost and this is the middlemost. So for any non-metal, if you see this is the nucleus and these are the orbits. Okay, not only one orbit or two orbit, any number of orbits. If this is the outermost orbit, if here the number of electrons are more, it like more than 4 or 5 or 6 or 7 or 8. So these comes under non-metals. Okay, 4, 5, 6, 7, 8. And if 1, 2, 3 are present, these comes under metals. Okay. In non-metals, you can see that the number of electrons in outermost orbit is more. Here you can count that 1, 2, 3, 4, 5, 6. Is it right? So free 6 electrons are there. So here no free electrons. You can see that completely filled. Almost only 2 electrons are balanced. So this comes under non-metal only. So the free electrons are very less in this. What we can say non-metals. So, hence, electrons are strongly bounded. Is it right? Electrons are strongly bounded. Then, in metals, the number of electrons in outermost orbit is less, like 1, 2, 3. Okay. Then, hence, the electrons are lightly bounded. So that what we can say, you can see that here only 3 electrons are there. 1, 2, 3 in the outermost orbit. So here we can see that they are not strongly bounded, they are free to move. Okay. So with the help of this structure, we can understand that the metals are having free electrons. So metals are having free electrons. We can disturb them easily. Is it right? So depending on the number of free electrons, substances are classified into three categories. One is conductor, have a large number of free electrons which are charge carriers. Okay, either one electron, two electron or three electrons, if they are present in the outermost orbit, they can consider as, we can consider them as metals, and they are charge carriers, free charge carriers. Okay, now we call them as conductors. And next one is insulators. Insulators are nothing but which are not a charge carrier. Okay, like a non-metals, wooden piece, glass, plastic, rubber, etc. So have less or partially no free electrons in that. So we call them as insulators. And one more is semiconductors, which can allow the charge partially. Okay. So here have the free electrons at a room temperature, but can develop under the specific condition. Basically, they are not having any free electrons. They do not have any free electrons at the room temperature, but under specific conditions, they will produce or they develop free electrons or specific condition under the specific condition, so that they can allow the charge partially, but not permanently. So like the SIM card is made up of a semiconductor. Okay, so semiconductors like silicon, germanium, that comes under semiconductors. With the help of we can develop the SIM cards. You can see that, and motherboards. You can see that IC, integrated circuit on the motherboard. They are also made up of semiconductors only. Okay. Now the task. A substance which do not allow charge to pass through it easily is called as, what we call, a substance which do not allow the charge to pass it easily is called insulator, conductor, semiconductor, or metal. So answer is insulator, because it do not allow the charge easily. Is it right? Negative terminal is called lower potential, lower electric potential or higher electric potential. Negative terminal is always called as lower electric potential. Is it right? So here, as they have concentration of the negative charge, so we call them as lower electric potential. The substance which do not have the free electrons but can develop under a specific condition are called semiconductors. We have studied just before. Semiconductors are the conductors which do not have the free electrons but they can develop under specific conditions. Is it right? The function of the cell is to create the potential difference only. Is it right? Not to create difference, not to create the drop, or not to develop free electrons, to create potential difference only. The function of the cell is to create potential difference. The flow of current in a wire. Now look at here. This is a wire, and here we are having some atoms. And between the atoms always vibrates in a free state, only at a particular position. And in between we are having some charged particles, charge carriers. Okay, free electrons in the state of random motion. Once the charge gets flows from one place to another place. Now initially they are in random position like this. Once charge gets flowed when it is connected to a battery. Now look at the electrons how they are flowing in a proper channel. Is it right? They are moving in a steady state now. So electrons move with a certain average drift. That is nothing but drift velocity or drift speed. Okay, the flow of charge uniformly. The uniform flow of charge is nothing but drift velocity or drift speed. Okay, so drift means average velocity or average speed. The flow of free electrons from negative terminal to positive terminal. Flow of free electrons. Okay, and conventional current from positive terminal to negative terminal. Okay, conventional current is always flows from positive terminal to negative terminal. But what about free electrons move from negative terminal to positive terminal? Okay, so keep it in mind here. The conventional current always flows from positive to negative terminal, and flow free of electrons can move from negative to positive terminal. Okay, potential difference is nothing but we know the difference between the higher potential and lower potential is known as potential difference. Is it right? So here we are having at A higher potential and B a lower potential. Both are insulated stand. Okay. Now metal wire. So here you can see that due to difference in potential charge will flow from higher potential to lower potential. Okay. As charge is flowing, work is done. Potential difference. The electric potential difference between the 2 points in an electric circuit is defined as the amount of work done in moving a unit positive charge from one potential to one point to another point is known as potential difference. Okay. Now you can see that how does lightning occurs basically. So we know that when clouds are hitting together and here light will the both are clouds are positively charged one. Is it right? Static charge. Clouds are at a higher potential, we know that, and as well as the earth is at a lower potential. We can say that earth is a zero potential body. Is it right? And now earth is a zero potential one. When the clouds are hit together, automatically what happens, the higher charge will flow higher potential to lower potential. Is it right? That is zero potential. Charge travel from higher potential to lower potential, that is from clouds to earth. Is it right? So that's why this lightning will occur. Is it clear? Now the electrons flow from the negative terminal to positive terminal of the cell, but the conventional current of the current is flows from positive terminal to negative terminal. Is it right? So conventional directional of current is opposite to the direction of electrons. The function of the cell is to create potential difference. The potential of the earth is zero. Okay, zero potential. As the earth is a infinity body, it has zero potential. Thank you.